need to find more smarter ways of building data centers and more efficient and sustainable ways of building data centers.
Welcome, everyone, to the Industrial Security Podcast. My name is Nate Nelson. I'm here with Andrew Ginter, the Vice President of Industrial Security at Waterfall Security Solutions, who's going to discuss the subject and guest of today's show. Andrew, how are you?
I'm very well, thank you, Nate. Our guest today is Vlad-Gabriel Anghel. He is the Global Product Manager at Data Center Dynamics Academy, or DCE Academy for short. It's a bit of a mouthful, but what he's going to be talking about is industrial cybersecurity at data centers. And, data centers are about more than just protecting the information. I mean, obviously, that's very important, but it's also all about physical operations and, electric power and cooling. Vlad develops educational programs that are focused on data centers, and industrial cybersecurity is a very important topic in the data center space.
All right, a new subject for us. Let's get right into it.
Hello, Vlad, and welcome to the show. Before we get started, can you say a few words about your background and about the good work that you're doing at Data Center Dynamics?
Of course, Andrew. First of all, thanks for having me. I'm Vlad. I'm the Global Product Manager at Data Center Dynamics' training arm, which is known as DCD Academy. I've been around the digital infrastructure industry for about a decade now, and I don't think that will change anytime soon, as I essentially have a deep passion for pretty much everything digital infrastructure, and especially data centers. I'm a thinker by heart and a problem solver by trade, and as well as that, during my high school years, I became a Cisco certified network associate, both in routing and switching and in security. So naturally, I now put my efforts together to ensure that the next generation of data center professionals are equipped with the knowledge required to run these complex technical facilities. In a nutshell, that's me.
Thanks for that. Our topic today is data centers, and we've never had anybody on from the world of data centers. Can you, sort of give us the big picture? What's a data center look like physically? And what are the operating priorities? I mean, at a power plant, everybody's worried about safety first. What's it like working in a data center?
Right. I mean, as I said, it's previously. I always, whenever I get into this type of discussion, I always say, what is a data center? It's the simplest question, but it has the most complicated answer. In short, it's a technical facility where a business stores, processes, and disseminates its data. Now, this can look. On the outside, they essentially kind of look the same. They are warehouses. You wouldn't even be able to figure out that that's a computing warehouse, so to say. There are multiple types of data centers. We're not going to cover all of them, but they vary based on the business that is using them. Right now, because of the advent of the cloud and because of the advent of Internet of Things, 5G, and now AI, one of the main things that we're seeing within the industry is the hyperscale segment. So the cloud providers, essentially cloud services provider, essentially, they're not able to keep up. They're not able to bring these facilities around quick enough. And when you add into the mix that there's a talent shortage in this industry, the problem becomes quite big. One of the main things that the data center always needs to do is what we internally within the industry call needs to be available. So availability is paramount. When a data center goes down, or when the IT load that data center supports go down, there are a number of repercussions. First and foremost, there can be contractual repercussions, so definitely a financial. It will take a financial hit, and as well as that, there can be reputational repercussions. Let's take, for example, a classic example of a bank. If the bank's data center goes down, you're not going to be able to check your account balance, or you might miss a payment that you need to do for your mortgage, for example, and so on and so forth. So this, a data center going down has a massive impact on both, as I said, the reputational and the financial outcome of a business.
So that makes sense. I mean, that is the picture I have of a data center, of racks of computers inside and a warehouse looking thing outside. But this is the Industrial Security Podcast. Can you talk about what's on the inside? There's obviously computers, but there's also infrastructure. What's that infrastructure look like? What's the automation on the infrastructure side look like, and what are the security concerns?
Certainly. I mean, to begin with, every single data center is going to have two what we call spaces within the industry, right? Every data center is going to be split into the white space and the gray space. The white space is essentially what you can see as the IT room, is essentially the place where you store your servers, your switches, your networking gear, and everything in between. And the gray space is everything that keeps the white space alive, so to say. I always have an analogy when presenting this to some students. You need to look at the white space as the brain, and the gray space as pretty much everything else in terms of lungs, stomach, heart, and everything else that allows the brain to function. When it comes to what's inside the gray space, because as you said, we're talking industrial security. Within the gray space, you've got the power distribution system. You also have the environmental control system, or the cooling system, simply because, and obviously all the other like control systems and softwares. These are usually managed through a SCADA instance, and because we've got because as I said previously, hyperscalers, for example, but not just that, like pretty much every sector within this market cannot build them fast enough. You now end up with facility managers that previously were tasked with managing one facility are now tasked with managing 5 or more facilities. Now, in order to be able to do this, because you can't be in the same place 5 times, the whole gray space and the whole equipment within the gray space is now connected to the internet. Now, again, as there's this separation between white space and gray space, so is the separations of the professionals working within these spaces. You'll almost always find IT professionals within the white space that are aware of cybersecurity in general and understand what the surface, what the risks are when connecting a device to the internet. Whereas on the operational technology side, or within the gray space, that is not common knowledge. So you do risk of having pretty much your whole if not taken care of, you've got your whole gray space, or the whole infrastructure that keeps the white space alive, prone to the same type of attack vectors that you can find within the IT space. A classic example, we all know it, and I'm sure it's been talked previously in previous episodes. The Stuxnet incident was exactly that. Was a worm that essentially buried into Siemens PLC, and then had a knock-on effect on everything else that those controllers were controlling, for lack of a better word. So the same thing can easily happen within a data center. And as we mentioned previously, you do not mention the D word, or downtime.
I think an important element of this whole discussion is that somewhere north of like 95% of organizations now use cloud computing, and the security of these environments is definitely on the radar of a lot of folks. Just this last Friday, when we were recording this podcast, the Department of Homeland Security announced that it's doing this whole cloud security investigation review, partly inspired by the fact that Microsoft recently was its cloud infrastructure was recently breached by Chinese threat actors. So this is clearly on the radar of many people and something that needs to be addressed.
That's right. In a lot of jurisdictions, data centers and similar facilities are considered critical information infrastructure, and so when there's reliability issues at these facilities, it's not just financial concerns and contractual concerns. A lot of the time, the government is looking over your shoulder, breathing down your neck, because this is critical infrastructure. When this kind of infrastructure drops, it's not just the business that suffers; it is society that suffers. It is commerce that suffers. It is government that suffers.
Yeah, although it occurs to me when you say that in the Microsoft case, the attackers were going after information. It seems like what you're talking about has more to do with reliability of these data centers. Now, I've some vague understanding that there are plenty of data centers out there with huge amounts of computing resources where maybe even if one does go down, the load can be transferred to another or to 3 or 4 others. Is that not the case?
I think generally it is, and this is reaching sort of the borders of my my knowledge here. But I do understand that in some jurisdictions, certainly the United States, I think Europe as well, in some jurisdictions, you're not allowed to move customer data out of the country or out of the jurisdiction in the case of the European Union. And so that would tend to reduce the number of data centers that could serve as your backups for those critical functions. Now, again, I don't know which jurisdictions in the world have these rules. I don't track this, but hypothetically, if you had a smaller jurisdiction that only had 2 or 3 or 4 data centers in, let's say, the country, and one of them fails, you've lost 25% of your processing capacity. You don't have as many options for some of those critical functions because of the law.
It actually reminds me of a conversation that I was having with some folks at a major software company, software as a service provider, who were talking about Black Friday, when everybody is on the internet all at once that whole weekend. And it's sort of like just there's so much less resource to go around. So they have to solve this massive problem of how do we use the same amount of infrastructure to serve this many people. And they were talking about, especially because, these centers can become overloaded and could cause one of them to go down. What happens in the worst case scenario? You don't want everybody's shopping websites to go down all at once. And just the sheer magnitude of the logistical challenge involved was impressive and intimidating. So I get the sense that there isn't a ton of unused infrastructure available, even in the cases where you don't have those regulations in place.
And that's certainly true, when, in Black Friday, certain days or times of the day or times of the year where, even if you have a lot of data centers around, there may not be that much spare capacity. Again, critical information infrastructure is sort of the message here. It has an impact on the business operating the infrastructure, but it also has an impact on society. So, this is the new reality.
I'm just glad that the cloud is up right now because our podcasting software uses that for backup files. So thanks to everybody out there doing Vlad's work.
Yes, indeed.
The latest numbers in the 2023 threat report on OT cyber incidents show that the threat environment has changed fundamentally at the beginning of this decade. OT cyber attacks with physical consequences have changed, from a theoretical problem to a very real problem, more than doubling every year. The new report is focused on deliberate cyber attacks in the public record. These are attacks that cause physical consequences in process industries and discrete manufacturing. Most of these attacks are ransomware, though the fraction of hacktivist attacks is growing. And the report's appendix includes a complete list of all cyber attacks since Stuxnet that meet these criteria. To see how today's OT cyber threat environment has changed, I invite you to download the report, a joint effort between Waterfall Security and the ICS Strive OT Incident Repository. You can download the report at waterfall-security.com/2023-threat-report, or just go to the resources menu at the Waterfall Security site and click on white papers and ebooks.
Okay, so preventing outages, reliability is king. But you said we're connecting these things to the internet. You've got remote teams. Can we talk about the data? What data is moving out to the IT networks? What data is moving out to the internet? What are people looking at remotely? What are people using remotely? Why do any of this?
That's a great question, and in a nutshell, I would say it's essentially remote management and ensuring that ensuring that the facility is within normal operating parameters. I'll give an example. Most of outages that happen within our industry are usually related to a power failure, but that power failure can happen in many ways. It can happen because of human error. It can happen because a static transfer switch or an automatic transfer switch failed to switch from the utility to the backup generators that are on site. It can be loads of things. And again, we're talking about mechanical and electrical systems. Mechanical systems will always be prone to failure. Most data centers right now are still being cooled using air. That air obviously needs to be funneled through to the actual servers at a particular temperature and at a particular humidity level. Should the humidity level surpass the normal operating parameters, you can either get a short circuit on the board or many other things. Small errors that you would not even be able to assign to, I don't know, something like an old operating system failure or anything like that. If one thing you will always find within a data center is an uninterruptible power supply. The power that comes from the grid for a data center, while good to have it's not reliable enough and it's not clean enough in order to feed it directly to a server or a switch, for example. So all data centers will connect their utility to the uninterruptible power supply. The uninterruptible power supply is essentially a big set of batteries that turns the AC current that comes in from the grid into DC current that can be eaten up directly by the servers and the switches. Therefore, because as I said, there is also a skill shortage within the industry, you do not have enough people to place them across all of your facilities to ensure real-time monitoring. Therefore, one of the data that passes through, as you pointed out, most of it is going to be related to remote management. And again, depending on the flavor of data center, that is going to be different. A colocation data center is going to have totally different requirements to a hyperscale data center in terms of what needs to be managed and what doesn't need to be managed. So I would say, like, in a nutshell, to sum up, most of this data is facility operating parameters. And as soon as something goes awry, someone is able to see it and act upon it before the actual load is lost.
So I'm not sure I understand here. You said you're looking at this stuff. The goal is uptime. You're looking at indicators of potential problems, especially with the power supply into the future. How far into the future can you see? I mean, if there's a lightning strike and a transformer blows out, we're talking near instantaneous. What kind of visibility do you have into that?
Right. It's not necessarily about utmost visibility on pretty much everything. In the example that you've described, you might have outside of the gray space, for example, you might have data being pulled into from a weather station. If you're able to see that a storm is going to come and you know that the utility grid you're connected to is not that reliable, your switching mechanism, your power switching gear, for example, will detect that there has been a loss of load on the utility, and then it's going to switch that over to the on-site backup generator, which is usually diesel. Obviously, there are other fuels, and the industry is exploring that massively right now. But yeah, another example in here would be you're interested in those status changes more like if you know that you're running on the generator for the next 7 hours, then you can think about, do I have enough fuel to run that generator for 7 hours in order to not lose the load? What happens if that generator fails? Do I have another generator that I can switch the load to? And so on and so forth. When it comes to the cooling side of things, for example, you're always interested to keep the operating parameters in terms of humidity, temperature, and stuff like that within quite close ranges in the white space. If humidity drops because your humidifier essentially died and you weren't notified, you like the actual facility manager didn't receive an alert that, hey, in data hall 1 the humidifier is no longer firing, that over time can lead essentially to static discharges that might actually fry the motherboard of a server, and you don't know, like in a colocation environment, for example, that server is owned by another company that essentially relies on you to keep it alive for them to be able to do business. So I would say that's kind of it, in the sense that you're interested in those status changes. You're interested to get as much data fed into as possible, both from the infrastructure side of things, the server side, the white space side of things, and as well as that, everything else that you can get your hands on. As I said, there are a lot of data centers that are directly tied into weather stations, so that they are aware of pressure changes coming in the next 2 weeks, wind speeds, and so on and so forth. There are other data centers, for example, that might have on-site power generation, like a wind turbine, and they could technically make a conscious decision knowing that, hey, we're going to have wind speeds of, I don't know, 30 kilometers per hour next week. That essentially means that we can disconnect from the utility and run on wind power for X amount of time, and we're going to save X amount of dollars at the end of the day.
Coming back to industrial cybersecurity, to me, sort of the cyber threat we worry about, if everything's connected, well, then everything's exposed. The bad guys can, in principle, get in and turn off power flows, interrupt the operation of the data center. So let's swing back to industrial cybersecurity. How are we preventing that? What's the you teach people how to do OT security for data centers. What do you teach them?
I mean, essentially, I've always said this. The answer to this is education. The contractors that are going to work within, the contractors or engineers that are going to work within the gray space, because they do not have this IT mindset, sort of say, or this cybersecurity mindset, they're not even aware that might be an issue. So therefore, it's classic stuff. Really, it's stuff like, have you checked what the remote login for that particular piece of equipment that you just installed is? Have you changed the default remote login? Oh, you haven't. It's still admin and 1234. Okay. If, for example, you bring a new generator in and you do not cover that particular attack vector, what you can just imagine, someone is, even like, again, and threats can come in from both directions. They can come in from the inside, from a disgruntled employee, for example, or they can come in from the outside. When it comes to, as I said, like my previous example, you just got a new generator in, but no one changed the default remote access credentials. Someone could possibly go in, put it in maintenance mode, then something happens to the utility. The power switching mechanism tries to switch the utility, tries to switch the energy from the utility grid to the on-site power generation, and the generator is in maintenance mode, so it's not going to accept the load, and you just lost the load. and again, it's like ostensibly these professionals, the ones working within the operational technology side within the data center, they essentially just need to be aware that, hey, there's a plethora of surface areas of attack. Just knowing which ones are going to be immediately available to someone can essentially just make a total world of difference. Another thing that we strongly enforce in our series of e-learning when it comes to cybersecurity is, if something like this, if you realize that, hey, this is a surface area of attack that no one has thought through, raise it up with your manager. Go higher. Ensure that it is put in a standard operating procedure. When installing a new generator, ensure that, to come back to my previous example, the default remote access credentials are changed, and they are changed to something that fits with the cybersecurity policy, for example, or the password policy, if you want, of the business.
So what strikes me here is that this all sounds very familiar. Patching passwords, remote access systems, don't be silly, don't leave a default password on the remote access system. And in a sense, maybe it's not surprising. It sounds a lot like what I see in other, standards and regulations like NERC-CIP. NERC-CIP is, North American Critical Infrastructure Protection for the power grid. It's all about ensuring reliability, not of the data center, but of the power grid. So, very familiar, focused on reliability. Begs the question, if this is critical information infrastructure, are there regulations in the space? Are there regulations coming in the space? And this is what I asked Vlad next.
Can we talk about regulations? I mean, other industries, the TSA just came down with, new rules for petrochemical pipelines 9 weeks after the Colonial incident. Similar rules just came out from the TSA for rail systems, passenger rail systems. There's, been regulations for the power grid in North America forever. There's NIST 2 now over in Europe. Is any of this affecting data centers? Are there cybersecurity regulations for data centers?
They definitely are. I will say that. I mean, one of our OT cybersecurity track was born of a need in, for example, in the US. If you're part of the state of New York, since 2018, if you have a facility that houses any sort of financial information, the engineers working within that facility are required to demonstrate cybersecurity training and refreshers every 6 months. That's just one example. When it comes to regulations in general, regulations have gotten kind of like, how should I put this? Have kicked into gear specifically after the COVID pandemic. During the pandemic, data center technicians were essentially classified as essential workers. And that was kind of the very first time when data centers came to the fore in the public mind. They were the things that essentially allowed us to continue working in the conditions like from home and working remotely and keeping in touch with people when we couldn't physically do that. Therefore, after that settled, a lot of people started realizing, oh my God, these facilities use a lot of power, without everyone actually thinking I also use a lot of digital services. So regulations are now coming to the fore in the sense that trying to essentially, from the design stage, enforce a sustainable and energy efficient design. For legacy data centers, they will be required soon within the European Union, for example, they will be required to share and make public the power usage efficiency of one of the several metrics, actually, one of which is power usage efficiency, which essentially calculates how much power you need to run the facility versus how much power you need to run just the IT load. The closer you are to one of a PoE, the more efficient you are. Obviously, that doesn't apply to every single type of data center, because if you are to implement liquid cooling in your data center, your PoE is going to go up there, but you're still going to use less resources. So there's this like the regulation landscape in a way. I feel like regulators are still trying to map their way through the industry. But when it comes to cybersecurity regulation, beyond everything that's already out there, when it comes, I don't know, to like payment processing systems, PCI DSS, and so on and so forth, for data centers, there's all that, and then there's another level, and the level that level will be dictated by the type of data that you house and store. As I started when I answered this question, in New York, for example, they're like, simple. This is going to be the law going forward. We need people to be aware that cybersecurity is something that needs to be of paramount importance, front and center into every professional's mind, regardless if they work in a mission critical capacity or not. Now, as time went on, other states in the US have also essentially just copied this particular law, and we're seeing it spread out as well.
So the regulations are changing, but data centers, unlike many other kinds of sort of very conservative industrial processes, data centers are way out on the bleeding edge of almost everything. What else is happening in the data center space? What new is coming down the pipe here?
That's that again, a very good question. And if we go back to my introduction, what's happening is the reason that I'm not going to change industries anytime soon, because right now we, as I mentioned previously, with the advent of AI, we need to find smarter ways of building data centers, and more efficient and sustainable ways of building data centers. One of the main gripes everyone has with the data center facility is the amount of power they use. That is not to say that there aren't data centers out there, for example, that are completely independent of the grid, or even better, using renewable power sources, created their own microgrid that feeds back surplus energy into the grid. Right now we've got people testing the idea of having small nuclear reactors on site to completely disconnect from the utility and not even rely on the utility per se. We're seeing more innovative ways of handling your cooling system. For example, oil and gas is a massive user of supercomputing. And when we're talking about supercomputers, we currently, the way we approach supercomputers is, hey, we just put a bunch of computers together and ask them to do the same thing. Now, for better or for worse, that is a data center. When it comes to highly intensive processing tasks, such as determining the depth and the type of material and the design of an oil well, for example, or where a particular oil lake or oil field is when it comes to going deep underground. These are highly intensive tasks, and because they are highly intensive tasks, they will require graphical processing units. Because they require graphical processing units, the temperatures that you need to work with go through the roof, because a GPU is essentially geared to work in normal operating conditions at around 90 degrees centigrade. When you have thousands of these, it becomes a problem. Air can only work up to, I would say, around 20 kilowatts per rack, if that. But then if we look at liquid or dielectric fluids, they can handle much more. So what happened with, because within DCD, we also have, within Data Center Dynamics, we also have an awards series where pretty much everyone from the industry submits their latest and greatest designs. And one that really caught my eye was a single-phased immersion cooling data center, which was built in Texas, but It was built by an Australian company. Essentially, what they did, they took your classic rack that hosts your servers and switches, put it on the side, and effectively created an immersion tub. They filled that immersion tub with dielectric fluid in a closed loop system. That dielectric, and then the servers, and because they only did it for the servers were dunked vertically, sorry, not horizontally. They go horizontal in a normal rack. Servers were dunked vertically with absolutely nothing on them. So all the casing was out, the fans were out, and the processor was in direct contact with the dielectric fluid. Being in direct contact with the dielectric fluid, it was able to cool it with much greater efficiencies, using way less energy in order to achieve those efficiencies. So that's the thing. It's like we are in a moment of, I would say, extreme innovation, simply because every single data center professional looks ahead and realizes that this is not going to change anytime soon. Simply like our need of, as a society, of digital services is only going to increase. Therefore, we're only going to need more data centers. We just need to get smarter at building them in a more efficient and sustainable way. So I'd say that's the main thing going forward with data centers. Everyone is looking for a paradigm shift in how to build and operate in the most efficient and sustainable way possible.
Earlier in the episode, Vlad was, I asked him about safety and reliability, and he, focused in on reliability right away as sort of the big priority here. But when we're talking about nuclear generators on site, I have to wonder if safety isn't gonna come back into the equation in a big way in the future. I worked in not a data center. I mean, I worked in the university data center full of supercomputers. This was 30 years ago. Back then, there were safety concerns in the data center. I mean, obviously, when you have large amounts of power, you've just got to be careful what you touch, that you don't get fried. That's a safety concern. But in some of these data centers, and I don't know if this is still the case, but back in the day, some of the data centers did not have oxygen atmospheres. If you were in there when the fire suppressive atmosphere was pumped into it, you'd asphyxiate. You had to have safety training just to set foot in these wretched places, because most of the time they were filled with an atmosphere that had no oxygen, so no fires could start. So you didn't want to be in there when the oxygen, or when the atmosphere changed. Again, what struck me about the automation and the cybersecurity concerns here, is that they seem very familiar, and it sounds like in the future might even become even more familiar as these designs move more towards a space where there are additional safety concerns on top of the top of mind reliability concerns that all critical infrastructures have.
Well, that's quite the vision for the future of data centers. It's obviously a field that's evolving very quickly. But coming back to cybersecurity, on the security issue for data centers, what are the main takeaways? What should we be thinking about for the industrial side of the data center?
Yeah, I mean, it's the way that I see it. It's quite simple, as it's part of as data centers are part of the mission critical. It's a mission critical industry. Downtime needs to be avoided at all costs. So I would say first and foremost is the old adage that we like in this industry is education. Make your professionals, make your engineers aware of the fact that this is even a possibility. Most of them are not going to be aware. You will protect your IT equipment or your white space. You will protect it from a cybersecurity point of view in as best as you can, simply because you're going to have the people that are able to understand this landscape. Whereas in the gray space, the professionals working in there have a totally different background, and therefore are not even aware of that this is a possibility. So I would say, just education. Always ensure that they know this is a possibility, they understand the repercussions of this, and as well as that, they know what to report if something goes awry, if something looks odd, they know how to report it up. And as I said previously, ensure that if an event happens, or if something, if a particular cybersecurity incident has taken place, that the steps to avoid that are embedded in the standard operating procedure of that particular facility. And yeah, I mean, if you're more curious about the world of data centers, just visit our website, datacenterdynamics.com. That's where you're going to find in-depth features on pretty much every subject matter within the industry. That's where you're going to find video interviews. That's where you're going to find the training division, which I'm responsible for. And yeah, the world of data centers is a wonderful thing, and I wish more people would be aware of it.
Andrew, clearly education is important in this space, but I'm wondering if there are any other takeaways that you got from this episode?
Yeah, well, the thing that struck me is that a lot of these systems, a lot of the concerns about cybersecurity, they're very familiar to anybody involved in any other kind of industrial cybersecurity operation. In particular, with the fact that this is critical critical informational infrastructure, and there's such a focus on reliability. I'm reminded of the NERC standards, which are also very focused on reliability. Some of the measures he talked about, teaching people about seem familiar there, and unlike the power industry, where power use is increasing a couple of % per year worldwide. It's a mature industry. Unlike that, the data center industry strikes me as still in its infancy. For I don't know what is it now, 50 years, everything has had more and more computers in it. Data centers have sprung up with more and more computers in them, more and more data centers. This is a growth industry. We're going to continue automating business. We're going to continue automating everything. There's always going to be more computers. There's always going to be more data centers, is what it sounds like. And the field needs expertise and experienced professionals. So yes, we need education. I'm wondering if there isn't an opportunity here for industrial cybersecurity people from other industries. For example, the power industry, the power sector, where it's a mature industry. I wonder if there's an opportunity for some of these professionals to switch fields and to make an impact in a growth industry.
All right. Well, thanks to Vlad-Gabriel Anghel for speaking with you, Andrew. And Andrew, as always, thank you for speaking with me.
It's always a pleasure. Thank you, Nate.
This has been the Industrial Security Podcast from Waterfall. Thanks to everyone out there listening.